Hi everyone, my name is Paras Chopra and I'm founder of Lost Funk. It was previously called Turing Stream, but recently changed the name to Lost Funk because the ambitions are much bigger. If you're wondering about what the name means, I'm pretty sure most of you won't be wondering about what the name means. Um, but if you're really wondering, it comes from loss function, the most important equation in deep learning that makes all of the AI tick. So let's talk about how to build SOTA models from India. So I already talked about this a little bit about me. I'm an entrepreneur turned deep learning researcher. Uh, Deep learning is something I've always have been in love with. I remember writing my first neural network 25 years back now in Visual Basic 6.0. Back then I was writing a three-layer perceptron, multi-layer perceptron solving XOR problems. But after that, I ended up starting a company called Wingify, which I bootstrapped to about $50 million in ARR. And very recently, I sold Wingify, and with all the time in the world, now I am aiming to build a foundation model AI lab from India called LostFung. So that's a little bit background about myself. Let's talk about why should India really aim to build SOTA models. Of course, I don't have to tell you, we have US with OpenAI, Google DeepMind, Anthropic, Meta AI, and now China has DeepSeek, Baidu, Quen, and a lot of other sort of new labs that you will get to hear about in 2025. It's pretty clear to me that a new Cold War is emerging. Stargate with $500 billion in investment in the US, um, and China with their response of about $150 million or $150 billion of investment into AI models. If you think about it, why are these two countries investing so much in building AI models? $500 billion is a significant amount of money, and so is $150 billion of investment. They are rushing towards investing just this bootloads of money into AI. Why would that be? I think answer to me is clear that AI race is about getting to a permanent leadership. A lot of AI Foundation labs started with this very expressed desire to benefit humanity. But if you start reading about how the narrative is changing, the narrative is really about how do you get to be the first and permanent leader. So I'll just quote this essay that recently came out by Dario a model. It is on his website. He's founder of Anthropic. What he says is if China can't get millions of chips, we'll at least temporarily live in a unipolar world where only US and its allies have the models. It's unclear whether unipolar world will last, but there's at least a possibility that because AI systems can eventually help make smarter AI systems, a temporary lead could be parlayed into a durable advantage. I think this is the last line is the most important one where he says that thus in this world the US and its allies might take a commanding and long lasting lead on the global stage. So this is not just some AI pundit talking about it. This is founder of one of the most prominent AI labs talking about how they want to get into a position of permanent and long lasting lead. Um, and I know there are critics, and I have a huge respect for Nandan Nilenkani and a lot of people who are talking about that India should not build their own foundation models. I think there is this debate, and I respectfully disagree. Um, it is pretty clear that the practical advantages of building a foundation model today does not exist. There is no point in replicating yet another Llama 3 or DeepSeek V3 or GPT-4o. The economic case doesn't hold true. You won't really build another model and be one amongst many. But I think what we are not really seeing is that the conversation should not be about where we are today, but the conversation should be about where the world will be in 5 to 10 years. Yes, it's true that we have Llama 3 open weights today, we have DeepSeek V3, but do we really believe that in 5 years we'll have Llama 10 and DeepSeek V10 very clearly available to us, just like it's openly available today? So let's not be fixated about where we are today, but let's be thinking about where we could be. And as we've seen Dario talking about, they want to get into a position of permanent leadership. And I think same is the true with China. So if everything is openly available today, it doesn't mean that it'll still be openly available in, let's say, 5 years down the lane. Uh, So if India really doesn't get its act together, if we together don't start building foundation models um, today, I sense that this is how it could play out. Of course, it's really a hypothesis, but everything that's coming together from a point of view of different countries like US and China, this holds true. I think either US or China could get to AGI first. A lot of insiders are talking about we could get to AGI, let's say by 2025 or 2026. If not that, maybe 2027. But it's around the corner. It's not like we're expecting AGI to happen in 50 years from now. Once the AGI comes, I think there will be very fast loop of recursive self-improvement. And this is not just a buzzword. Let's not be fixated on recursive self-improvement as a buzzword. Today also, you may know that most of the software people have started writing through Cursor and Bolt. And more and more labs will start doing things around AI research through AI itself. So you will have architecture search, hyperparameter sweep, paper writing, paper discovery, a lot of things advanced AI models will start doing themselves. And once that happens, I think we will very soon surpass. This is a fast takeoff scenario that we will talk about. Once you get to the AGI, then you'll get to super intelligent models very, very fast. And whoever gets there first, let's say China and US, it's very likely they will embargo model weights and research also so that nobody else gets access to it. So the embargo in China that's happening where they have like limitations on GPUs like H100s, um, it shouldn't come to our surprise that once even more advanced compute, even more advanced models, even more advanced research it's out there, that we won't have embargo in other countries as well. Like you couldn't predict that whether India will also have embargo. So why are we assuming we'll have Llama 5, Llama 6 access once they get there? And once these folks get into a super intelligent model kind of a scenario, it's clear that other nations will become dependent on either US and China. Um, so just to reinforce, there is this Palantir CTO talking about the very similar
I think
point.
one of the obvious lessons of DeepSeek R1 is something that we've been saying for the last 2 years, which is that the models are commoditizing. Yes, they're getting better across both closed and open, but they're also getting more similar, and the price of inference is dropping like a rock. But I think the real lesson, the more profound one, is that we are at war with China. We are in an AI arms race. And I got into a disagreement with Sam Altman about this at the Senate AI Summit over a year ago, where I was arguing that we are in an AI arms race, and there's an opposing view that we can all get along and we can cooperate on these things. And I'm sure the other side feels quite different, realizing that their IP has been stolen in this process here. But this war started long ago. It was an economic war with the ascension of China to the World Trade Organization, the greatest IP theft in history, the greatest wealth transfer in history. It is an opium war. The #1 cause of deaths of 18 to 45-year-olds in this country is fentanyl. That is coming from China. It is a diplomatic war. The Belt and Road Initiative is basically indentured servitude for other countries to the CCP here. And the unprecedented phase zero gray zone operations of the CCP, how many times are we going to believe that anchors are dragged across the sea that cut undersea cables here? But I think one of the things, China knows they're at war. The question is, we kind of equivocate on it as a peace-loving nation. But one of the things I want to make sure we all do realize is that the engineering in R1 is exquisite. The optimizations that they've done are really impressive. And I don't think you can get away with the facile explanation that the Chinese just copy and we're the only innovators. We have to wake up with the respect for our adversary and realize that we are competing. But they absolutely did steal a lot of that through distillation of the models, and perhaps they stole even more. And then you can look at the GPU sales growth in Singapore. It's a tiny island nation. I'm pretty sure there's some sanction evasion going on there. And we have to realize that the AI race is winner take all, and it's going to be a whole of nation effort that extends well beyond the DoD in order for us as a nation to win. And that M-Day was yesterday. The time to mobilize has come.
Yeah, so if you notice, there is the whole language is about war, AI wars, race, mobilize, and all that. And this is Palantir, a really big organization that helps US defense. And so this stance of almost war-like focus, both China and US has. And I think we must ask ourselves, does it make sense for the world's most populous country, ourselves, to be left behind permanently? And the answer to me is just pretty clear. We can't just be left behind while US and China are focusing so intently in winning the so-called AI arms race. So I think just like nukes, AI has become a matter of national security. It's pretty clear world's two most powerful nations view it as a matter of national security. That's why they're investing $500 billion, $150 billion. And talking in this language of mobilization, DOD, embargoes, and so on. Um, so just imagine that if 1970s we had not done Pokhran tests. Just imagine we did not have the foresight to do and develop our own nuclear weapons. I think today we would have been in a position of really frightened nation with our neighboring countries having nukes. I mean, just see what happened to Ukraine, right? There's just like a helpless country there because another country with nukes is just sort of bombarding them. And I think the same foresight we need today. We should not be looking at what's possible today, but how things could evolve in, let's say, 5 to 10 years. Um, so I'm pretty convinced, and I hope you are convinced too, that India does need super intelligent AI models that are homegrown, that we can build and consume ourselves so that we are not permanently left behind from any other nations. Um, Otherwise, I think in, let's say, in 2030, we might be importing Chinese values. You ask DeepSeek, tell me about COVID protests in China. This is what it ends up saying. Do we want that? I'm pretty clear, as a democratic nation, we don't want that. So building cutting-edge AI models from India is important. I hope we all can agree. But can we do that? I think a lot of people also doubt that as Indians, we can't build really cutting-edge stuff. Everything is happening in Valley or China. They're so far ahead. What do we do? But I think we don't have to look too far to answer whether we can do cutting-edge stuff. I think Sriharikota is just 6 hours drive from here. If you've never been there, I highly recommend to go there and take a look at the rockets there. I've been there, and it's just so heartwarming to see this whole 20-foot, I don't know how big these things, I think 30-storied buildings right in front of you, and it just feels interesting. And I'm not sure how many of you have seen those photos where the first rocket is this small, and it's been sort of carried on a cycle. From there to here, it's just a matter of foresight. You obviously can't get to this on day one. You obviously can't get to O3 level models on day one. But if you don't even begin, how would you get there? So it's all about the foresight and the vision. And as a nation, I think we don't have to look too far to see. We have done and we can do a lot of amazing things that's our best in the world. So how do we build ISRO of AI from India? I think more GPUs is not the answer. And when I was looking at this chart of GDP per capita of US and China and India, I had to look multiple times to see whether I was looking at the right number itself or not. And actually, I had to do calculation and mind. I knew that, but still my mind was blown that India's GDP per capita is 3% of the US. I think being in Bangalore, probably sometimes we end up forgetting that our GDP per capita is quite far behind US and of course even China. So it's really clear we can't outcompete US and China on sheer scale of investments. I think it would be unfair for us on the government or the private industry or investment industry to expect that we can get $500 billion of investment for it. I don't think that's the answer. I don't think then 1/5 of the world's population must have the most number of geniuses out there. It's just true by definition. You just multiply two numbers. Instead is breakthroughs that come with our brain power. If you imagine intelligence, human intelligence to be distributed on a curve like a normal distribution, then 1/5 of the world's population must have the most number of geniuses out there. It's just true by definition. You just multiply two numbers and you would get, where would the most number of geniuses be? India. And the proof is in the pudding. It's just not a hypothesis. This paper that kickstarted everything. Everything that you see in Gen AI today, attention is all you need. From primary authors, two of them are Indians. And not just Indians who've, let's just say, Indian settled, let's say they were born in US, they actually studied in Indian institutes. Ashi studied in BITS Mesra, Nikki studied in Pune Institute of Computer Tech. So this was done from Indians as primary authors. And from a hardware perspective, the attention is all you need paper. The first transformer model was trained in 12 hours on 8 GPUs. And I think I'm pretty sure all of you here can do this within $20 today if you want to do that. So it's the breakthrough is not out of reach. It's just probably out of imagination. And if we put our imagination, we can get there. Just not the old attention is all you need. If you see, there was this Neurops, the top conference on neural networks in the world. They had this efficiency challenge, and you see the winners. India, 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 India. And so we are going out there and winning these challenges on NeurIPS, which is like an amazingly big and I mean, it is the number one neural network conference out there. And of course, who created PyTorch and who co-created TensorFlow? Again, Indians. So I don't know how much more proof do I need to show that we are capable of doing it. And I think a lot of people say Indians in the US do it, but all of them have studied in India, and I think that's the important bit. Their education, their brain power, everything is just very Indian. But I want to come back to the bitter lesson. I think if you've just spent any time thinking about this problem, the bitter lesson just keeps staring you in the face. For those of you who don't know about the bitter lesson, it's all about the hypothesis that scale is what matters, that you build big models, you throw a lot of compute, and that's how intelligence happens. And wherever we put a human ingenuity, someone with more compute and data can simply outdo you. Um, I think it's somewhat true, but it's also it's also something which you can work around with creativity and a little bit of intelligence, and we'll see how to do that. I think the proof of existence against bitter lesson, in some sense, is human brain. Human brain is an extremely efficient AGI. It runs on potatoes. You eat potatoes and you have an AGI. You don't need this nuclear power data center to run an AGI. And it's just not hypothesis. We all have an existence within ourselves. It's highly data efficient. I'll give you a few examples and you grok the whole pattern. It's not like Llama 3 where you need 15 trillion tokens. It can adapt quickly. If I tell you a game that you've never seen before, I just need to tell you rules once and you understand it immediately. Unless a lot of models where you have to just keep feeding in them tons and tons of data to keep fine-tuning them and so on. And it's highly general, from chess to poetry to plumbing. This thing can do everything. So if anyone tells you about the bitter lesson, I think you should keep thinking about, we have a very personal counterexample to bitter lesson, which just runs on potatoes, right? How did human brain become so efficient? I think that's also a question. If we are throwing tons of compute at AI models, I think the answer to that is evolution. Evolution doesn't like wastage. Any organism that wastes anything, it gets outcompeted by another organism. So when you're competing for limited resources like all our ancestors have done for billions of years, the first life arrived on Earth, actually a billion years or so. After that, just there has been a competition for resources, and it has driven human brains to be more and more efficient. So who else is competing for limited resources? Who else has been competing for limited resources? It's the Chinese labs like DeepSeek. And it's so interesting that these constraints and limited resources end up pushing for efficiency into areas that nobody else thought is possible. Why did US companies not produce something like DeepSeek? The answer is clear. They had tons of funding, and there was no incentive to really work around that funding and find clever ways to scale things up. Or only when you have these embargoes, only when you have these constraints, only when someone denies you something, that you rise up and see, how do I work around that? Otherwise, just you are swimming in funding, and there's just no incentive for you to think creatively. So I'll spend a couple of slides talking about different innovations that DeepSeek did. This is the only technical part of my talk, but I think it's worth spending time on DeepSeek to see what they ended up doing. For example, the first innovation they did was multi-head latent attention. Everyone assumed, and it is true, that the key value cache of these large models grows quadratically, which limits the size of inputs and outputs that you can produce. And everybody assumed that either you use inefficient ways like linear attention, or you do this group query attention and so on. What they did was pretty clever. They took this KV cache matrix, which grows quadratically. but they came out with a low rank approximation of it. Excuse me, what they called as compressed latent KV. And this helped them dramatically, like processing longer inputs. And because they could process longer inputs and outputs, they could produce a long chain of reasoning, which just led to the reasoning model that you see in very limited constraints. Again, very, very creative. Nobody else thought of it. Everybody had given up that maybe KV cache, you can't compress much, but they just went ahead and did this. The second they did was multi-token prediction. Everyone for the last, I don't know, 5 years has been predicting a single token. Uh, they just asked themselves what would happen if you predict multiple tokens at once. And it turns out that if you're predicting multiple tokens in advance, you are forcing the model to do a much harder job. You don't have to just do the second token, you have to predict the third token as well. And this feeds back much richer representation that makes you more intelligent. The third innovation they did was smarter mixture of experts. And mixture of experts is a architecture that you end up doing when you have to save money on inference or training, because you are able to isolate different parts of the model in different GPUs. But again, everyone was doing either let's just route it to the so-called best experts or route it to fixed number of experts. Their innovation was to think about that the intelligence is comprised of two parts. One is the general things you need. For example, English grammar is what you need for anything you need to answer, and they called it, let's say, the shared expert. And the other things are very specific, like coding or world knowledge and so on and so forth. And they called it the routed experts. So shared experts are what are called all the time in all the queries, and routed experts are chosen dynamically. Again, very, very clever. And that was not all. I think there are tons of other innovations. In fact, probably the biggest innovations they did was to get to CUDA, and not just CUDA, PTX level. So NVIDIA has this intermediate language called PTX, and they ended up getting to that level to work around memory bandwidth bottleneck. They were the first ones to also do FP8 precision training, and everyone thought that you can only do training in FP16 or FP32. They just went ahead and did in FP8, which means they could do it on smaller GPUs, and they also innovated GPRO. So it's amazing, the single paper containing so many innovations, and all that helped drive the cost for training and inference by 10x and 20x. Of course, this whole headline number of $5.5 million, I think it's a little bit exaggerated. A lot goes in the background to get to a model that you can finally train in $5.5 million, but it is true that they didn't have resources of OpenAI. They were able to do it much, much more efficiently. And not just in training, inference also. If you see DeepSeek's per token cost, it's 10x lesser than the other models. So I think we can all agree that creativity is born out of constraints. And it's just not DeepSeek that's been efficient. I'll just give you 3 or 4 more examples of people doing amazing stuff with very less amount of resources. I think this is first model is Kokoro 82M, which is state-of-the-art text-to-speech model trained in just $1,000. So now 11 Labs has raised $100 million. And this is, I'll just play you a sample. This is $1,000. Can you play the audio?
Kokoro is an open-weight TTS model with 82 million parameters. Despite its lightweight
maybe a little bit more.
architecture, it delivers comparable quality to larger models while being significantly faster and more cost-efficient. With Apache-licensed weights, Kokoro can be deployed anywhere from production environments to personal projects.
Yeah, so this is $1,000 instead of $100 million that 11 Labs. How did they do it? Again, they were very creative. They took like a larger academic model. They ablated layers of that model very, very creatively, so that at the end they left with an 82 million parameter model that they trained with very high quality data. The other example is this lab, Sony AI lab. They trained a SOTA diffusion model in under $2,000. So the images that you see on the right, it's not stable diffusion that raised, I don't know, $200, $300 million. This is $2,000. They were able to do it. Awesome. Okay, so we know constraints truly breed creativity. And Now, a couple of points on the roadmap to build SOTA models from India. We know that there is a global AI war and India cannot be left behind. We also know that this is why we ought to build our own SOTA models. And we also know that Indians have done this. And we also have lots of examples of how people have done this in extremely frugal budgets, but through their brain power. And we also have an example of this efficient AGI that runs on potatoes. But how to get there? I think the first number one thing, which for me is just super, super important, the most critical is have global ambitions. I think Indian LLMs are great, and we need a lot of focus on solving India's problem, but we need to aim to be SOTA in the world. Unless we are aiming to be state of the art at something, it doesn't have to be state of the art at. We are aiming to be state of the art at something, it doesn't have to be state of the art at everything simultaneously. But unless we are aiming to beat some global benchmark, some global aspects of being best in the world, will not get there. Unless you aim to be the best in the world, you'll not be the best in the world. It's as simple as that. So I genuinely believe we don't lack in talent or funding or even creativity. I think we right now lack in ambition. And only if our ambition is like 10x and 100x can we get there. So having global ambition is number one priority. I think number two priority or the point which is important is also to build on top of other models. Uh, Sometimes you can swing too far in the opposite direction and say we have to invent everything from scratch. We're not inventing our transistors, we're not inventing our operating systems. So why just say everything has to be homegrown? I think we should be utilizing whatever we can in the open source community and build on top of it and to go beyond it, which means there is no shame in starting with distillation, pruning, quantization on. Think of open source models as a free resource. Llama has spent $100 million and given like a bounty for everyone in their pre-trained models. There is Allen Institute where they have open source their whole training data. There is Corpus and so on. So we don't have to build everything from scratch. We can and we should build on top of other models. And I think third, not a lot of people like this word, but I love it. I think we should be using a jugaad mindset to pursue efficiency. Poor. I don't think this is absolute GPU poor. We'll be relative GPU poor nation for a while. So I think we need to make the best out of the resources and very creative. I think when we are faced with constraints, we really end up impressing ourselves and everyone else. So if we use jugaad everywhere, why not use jugaad here also? And jugaad doesn't necessarily mean hacky. For me, jugaad really mean pursuing an outcome in a very creative and unexpected fashion. We don't have to follow everyone's path. We don't have to follow necessarily the path that OpenAI DeepSeek is seeking. We can create our own path. We are very creative that way. We can create our own path. We are very creative that way. And fourth, I think we need to invest in talent. We cannot expect to have top talent across the world to move in India unless we start paying them an equivalent amount of salary. I think it's pretty clear nobody likes to let go of the economic opportunities they have, and we should not be expecting it. And this is what also China did. China, I think they had a top 100 researcher program where they scouted the US and saw who were the top Chinese researchers in US doing amazing stuff and just paid them through the roof and got them back into the US. So we don't need all the researchers, Indian researchers in US to do so, to relocate here, but I think we need a critical mass of people from US and other places who are doing great stuff to come here and seed that culture so that we can do a lot of amazing stuff around it. I think it'll be unrealistic for us to appeal to people and say you need to maybe let go of their economic opportunities. And this is realization we need to have. Top people will demand top salaries, and there's just no way around it. And I think second last is invest in computer infrastructure. Yes, I think creativity is great, but we need both creativity and compute. The bitter lesson still holds. Unless we have an algorithmic breakthrough that gets us to human level AGI in 20 watts, we are competing on a very different, very similar trajectory. And for that, we need compute. And I'm very excited and happy that India's AI mission, they are sponsoring models. And I encourage all of you to take a look at their grant proposal, request for foundation model, and submit a proposal of your own. And I think sixth is taking an ecosystem approach. None of us will do this by ourselves. We need to figure out a way how we can lift the entire boat together. How can we collaborate? How we can have both enterprises and universities come together. I don't want to do it just for myself. I think it will be awesome if the whole ecosystem lifts and India starts getting known for producing breakthrough AI research. India starts getting known for producing breakthrough AI research. Yeah, so ask yourself, are you interested in helping build this? Should India's flag be there with US and China when anyone is talking about AI and breakthrough AI? I'm certainly very excited. And we need many, many parallel teams to try to build SOTA models. I'm just throwing my hat in the game also. So I'm hiring at lostfunk.com. If you're interested, go check out. It's a 3-line website. You won't find much, but you'll have a form to apply if you are interested in this. And I think this is a take-home message that I want you guys to think about. That I think SOTA from India will not just benefit India. We have a real opportunity to be the leader of a multipolar world by building AI that benefits the entire world. For good or bad, good or bad, US is sort of antagonizing its allies, which is crazy. I don't understand why would you antagonize your allies, but it's happening. And China, of course, people have a lot of fear with that. So I think if India rises, we have an opportunity to not just benefit India, but to benefit entire world and entire humanity. Because as a democratic nation, I think we have a great opportunity. I think if we do that, it's building AGI from India in the world will actually be like having our own permanent seat at the UN Security Council. We might not even need that because we'll have an AGI pretty soon after a super intelligent model of our own, and we won't be dependent on anyone. So yeah, let's aim to build an ISRO for AI starting 2025. It's a perfect time. We're at inflection point, so why not aim that? Awesome. Thanks. That's all.